It's time to go home.
All right.
And that directly relates to...
Okay, so now that the recording's on, we're going to talk about series parallel circuits. And I think by now a large majority of you have already done series parallel 3 on the computer, right? Mm-hmm. And so you already know how to do it, so hey, relax, you can, do easy. So the thing about series parallel is you already know how to do series, and you know how to do parallel, and you just have to put the two together. And if we look at something and what you have to do, it's a bit of a puzzle. And sometimes the puzzles are relatively easy. Like if I do this and this, I can see that I have 1 in R1 is in what? Series, and R2, R3 are in parallel. All right. And now I have to start getting some examples out, or this is not going to go well. All right. Let's just move this. So, okay, so the secret to doing this then is first you have to simplify. And I can simplify it into something parallel, or I can simplify it into something series. And it just depends on how it's laid out. This one I would simplify into something series. So I've got to make my R1, which is just R1. I just bring it straight down, and R1 stays R1. But now I've got to make a resistor here that is R2 plus R3. And it's the sum of these. And by the sum, you know that it's actually I would say the inverted, the reciprocal of the actual resistance. So, as an example, we'll do a real one here. All right, so we got R1, R2, R3, 4. Bring it back around. Okay, so R1. And by the way, if you don't label your stuff, Tom's going to get you.
Yeah.
All right.
Nail me one.
Nah. All right. And he's right. So if we have 0.25 ohms and 2 ohms and 3 ohms and 1 ohm. 1 ohm. What's that? Okay, 1 ohm. We have to simplify that down, and all I want to do on this one, let's see. Oh, no, we can do the whole thing. E, I, and R, and we'll say that this is 24 volts. And I find the secret to doing this is you actually kind of have to keep things neat, and it's probably going to be a little difficult for me to do it with just one screen. I usually use the whole boards to do something like this. We'll have to scroll back and forth, or you're going to have to keep notes, and if it's on a test, I'll have multiple pieces of paper. I'll even do it, depending on how big the project is. But what you have to do is you have to simplify. So we're going to simplify this a little bit. In fact, I'm going to simplify it right now by taking out some of this so I can use some of this space over here. We'll just do this, right? That's cheating. Okay, so to simplify, I'm going to end up with 3 resistors. 3 resistors. There's R1. There's R2. And this is R3 plus 4. All right, so R1 is still, and we can still do the EIR. Still do that. EIR. EIR. All right. And let's see, what is R3 plus 4? 4. Okay, so we got 3 ohms here and 1 ohm there. No, it's not 4. They are in parallel. So, all right, so I've got to add them in parallel.
You got me there, Kevin.
Surprised you're even awake, all right. 0.8, I got 0.75. So that becomes 0.75 ohms here. Well, what is R2? Still 2 ohms. And this is still 0.25 ohms. Now this is not a terribly difficult one to solve because we brought it down to a simple series circuit, and I can put E total, I total, and R total right over here, which is going to be the same over here. That's not going to change. Total is total. So if I know this is 24 volts, and this becomes then R total is what? 3. Okay, well, that doesn't change. This is still 3 now. So 3 ohms is 3 ohms is 3 ohms. So total. All right, so what is my current flow?
8 amps.
8 amps. 8 amps. Okay, so using Ohm's law and Kirchhoff's law, I can complete this. 8 amps, 8 amps, 8 amps. 2 volts. 8 times 2 is 16 volts, and 8 times 0.75, 6 volts. All right, so we've solved this right here, which means we can actually solve for up here. So I'll put this here, EIR for 1, EIR for 2. This is 0.25, we knew that. This is 2 ohms. This right here just comes up, 2 volts, 16 volts, 8 amps, 8 amps. All right, so that's that. But what you have to do now, this becomes the total that goes into here. Yeah.
I just want to go back real quick on how you got the resistance for the parallel section.
Oh, excellent. I'm glad you brought that up. Okay, so how did I get this right here, this 0.75? Okay, it's 3, 1 over x, plus 1, 1 over x, equals, and then 1 over x key.
Okay.
So reciprocal of those. So that gave me this. So this becomes R3 plus 4 is the total for these two. So it's like the battery is here now. This is like the battery for this. So if I have a battery going into a parallel circuit and I have 6 volts, and this is 3 ohms, and that's 1 ohm. That didn't change resistance. Okay, what's the voltage?
6 volts.
Okay, 6 volts, because 6 volts and 6 volts. Everybody see that? Because if you can't, I can redraw it in a way that might help. All right, so that's 6 volts. Now, the interesting thing here is what happens to the current when it gets to this point?
It's like separate.
It's got to divide out, right? So it divides out. So we've got 8 that's going to divide out both ways. So what goes here? 2 and 6 amps. All right, 6 plus 2 is
8.
8. So I got to double check. It's all right. Not hard, was it?
Wait.
No, wait.
How did you get the 2 amps over and 6 amps?
How did I get the 2 and 6 amps right here? All right. 2 things I want you to notice. 6 plus 2 is what? 8.
So what's the
Remember Ohm's law? E equals I times R. If I want to know I, what do?
E divided by R.
E divided by R. So 6 divided by 3 is 2, because I knew 2 things. So I knew 2 things, so I could find the third. I found the third, and then I said, hey, wait a minute, let's double check that. Is 6 plus 2 equals 8? Got it?
Yeah.
All right. Do another one?
Yes, please.
Okay. You're gonna need some more paper. Oh, I know what that is. Okay.
Kevin, is there
Yeah.
any problems where we're gonna have to actually simplify the parallel, or can we always just keep it? Like just not simplify, not R3 plus R4, but just R3 and R4. Like, because on the DC challenge we didn't simplify the parallel.
You didn't have to simplify?
No. I mean,
I don't know how you managed to do that.
I just have like 4 resistors, and then just write the EIR for each one.
Wow. I don't know how you managed to make it through that then. Must have had DC Challenge 1.
Pretty good.
They have Kirk's crosswalk and
Remember he said there's 100 different formulas?
the ones that work the most.
He said there were 16.
All right. EIR. R1, 2, R3, R4. Total. Now I'm just wasting time. All right. Let's see. What are my givens here? Hang on 1 second. All right. What color am I at here? Let's go black. So 36 volts is a given. 2 ohms. 6 ohms. 12 ohms. And 6 ohms. You want me to do it with you, or you want to do it yourself?
Myself.
You can do it.
I don't mind. Or I can just, well, I don't want to do it quietly because I'll give you a minute or two.
Sure.
All right, we'll work it together. So we're going to simplify it into, again, 3 resistors. We've got R1, R2 plus 3, and R4. All right, so EI and R, EI and R, and EI and R over here. All right, this stays the same. That's 2. Oh, we'll put EIR total over here. So that's 2. This is 6. All right, that's a given. 2 goes to 2, 6 is 6. But now we got to figure out this. So what is it going to be? I know it's not 6. What's that?
I was going to say 6 1.
Oh, you're going to say 6. 6, 1 over x plus 12, 1 over x equals 1 over x, 4. Well, does 4 sound right? 6 and 12, is that 4? What's that?
Lower than the.
Lower than the lowest. So, okay, we got that going. And we have a given of 36 volts. So now we can just add this up. So we have 12 ohms, which gives me
3 amps.
8.
3 amps per ohm.
3 amps sounds better. Did you say 8?
No, it's only 3.
Oh, 3. Oh, sorry. Okay. 3 amps. So how many amps here? 3, 3, 3. All right. So we have how many volts? 6 volts. 12 volts. 18 volts. All right. So we can transfer some of this over to here now. So R1, that's just the answer. So 6 volts, 3 amps. And down here, because it's just still R4, that's 18 volts and 3 amps. But now we've got to solve for this right here. So I'm going to put this kind of, to solve for this.
12 volts, 12 volts.
But to do that, we take this is our totals now. So this is like the battery going into here. So it's parallel. So what is it, Brett?
12 volts.
12 volts. So they're 12 volts, man, 12 volts. All right. Now, to find I, what do I do?
Divide 12 by.
Whose law? Ohm's law. So remember E, I, and R. I want to find I, so it's E divided by R. Well, 12 divided by 12 is?
1.
Are you sure about that? And 12 divided among 6 is? 2. All right, so now I'm going to stop right there and say, okay, wait a minute. I have 6. I'm sorry, I have 2 and I have 1.
3.
3. Does that equal 3? Yep. So 3 amps are coming through here, going through here. Ooh, look, 3 amps right there. I was right. 3 amps. 1 of them goes this way. 2 of them go that way. They meet back up, and we have, again, 3 amps running through the system. That's easy. All right. Another one?
Yes.
All right.
This is the handout. Computer. Stand on my right there.
Now, how is this one different from the last one?
There's only 3 resistors.
Is it same or different?
It's pretty simple. It's the same.
It's the same. You just
Well, is this-
Lost a resistor.
That's true.
Just 3 resistor.
It's only
Was
3.
4.
All right, do blue.
Check that out.
36 volts. This one actually gives the amps, so that's kind of easy. 4, 12. Ooh, they don't give you anything there. Mean. 6 amps. I don't know if we're going to do that one. We'll give it a shot, see what happens.
There isn't anything on the second one?
No, I've got some examples out of a book. I don't even think I've got a key for that one, or I've never worked it. I don't know. Let's see. Let's start this. Okay, so sometimes you have to redraw it. So, all right, so I've redrawn that, so now you can see it very plainly that it's a series and a parallel. So knowing that, we just come back over here and do what we know how to do. All right, so what can we fill in that we absolutely know? Just start with what you know.
4 amps.
4 amps.
All right, we know that. So 4 amps, and I can even look at this. So I have 4 amps is coming through here. Do I know the voltage drop here? I have no idea right now. What do I, oh, there's 4 amps going through there. There's 4 amps going through there. Okay, I've got that. And so there's 4 amps here, and this is a given. 6 ohms. I know nothing here, right? Just about clueless I can't transfer anything from here over to here right now. But because this is just a simple series circuit, I know that 4 amps is right there. And I know that to find E is I times R. I know that I can find E because I have 2 things, right? So E is what? 24 volts. Whew, okay, this isn't so bad. Okay, and, well, can I do anything with this now? I've only got one thing.
Yeah, you can. If there's 24 volts there, and you got 36, and it's voltage drop, then just subtract the
Yeah.
24 from 36.
So my total is 36. So 36, 24, what's left over? 12 volts and 3 ohms. Hey, look at that. Okay, so you're halfway there.
Now shoot your 12 volts over.
Okay, so this is the same, 24. Bring that over here. What's that, Brett?
Just shoot that 12 volts, because that's your battery source now.
12 volts and 12 volts, right? Because this, remember, this becomes my battery. Yeah.
Oh, that's cool. How'd you get that 3 ohms again?
How to get the 3 ohms?
Yeah.
Ohm's law.
Oh, okay.
I had the 12 and I had the 4.
Never mind.
Simple math.
Simple.
So this now becomes my battery supplying this right here.
Yep. Then 12 divided by 12 is 1 amp.
So if it's 12 going to parallel circuit, it's 12 and 12. All right, got that. I still don't know anything over here. So 12 divided by 12 is 1 amp. Okay, but now here's, huh?
Let's say your total's 4 amps, and if you take your 1 amp away, then you got 3 amps.
There you go. Coming into this was 4 amps. 1 went this way, so how much went this way?
3. Then you just Ohm's law.
Just Ohm's law it out, which is 4
I'm gonna
ohms.
say 4, Kevin.
Gonna say 4? Gonna go 4.
That's my final answer.
Then if you actually calculate it out, that will be 3.
Oh, then we still have to do this right here. So how many ohms? Yeah, just do
Well,
Ohm's law
that'd
right
be
here.
9 ohms, but I meant like if you did the parallel,
Yeah.
converting it back to series, then it makes it. I have to double check or something.
Okay. So what do we got here for ohms?
9.
9.
So I mean, technically, you could have solved
No.
totals
Those two together.
right away if you wanted to. Checking your work.
No, I don't think I could have got this. Oh yeah,
Yeah,
because
you
36
did.
and 4, so 9 is right there. But it still makes it kind of hard because you didn't really know. Let me see. This was a given here, I think. So 6, and you would have known that you're back down to 3. But I really didn't show you how to work it backwards. How if you have 3 ohms, then what must these two be? There is a formula for doing that, but it worked out just fine. One more? Yeah,
Just before you go,
Just
how
before
did you get on R3
R3.
4 ohms of resistance?
R3. How did I get 4 ohms?
Yeah, but
Ohm's law.
12 divided by 3.
then what are the 3?
4 times 3 is 12. 3.
The amperage is divided up.
Let me go back just a little bit, okay? Because I know sometimes Justin's writing stuff down. And so what we ended up with at one point was, let me see, we didn't know that, and that's where we kind of ended up. Okay, so we'd figured out, because we brought 12 and 12 over,
I see.
and because this 12 was a given, right here, the 12 ohms resistance, I used Ohm's law to find that I had 1 amp left.
Right.
Okay, now,
So whatever's remaining,
well,
4 amps.
out of 4 amps, I knew that I had to have,
3.
color map, I knew I had to have 3 amps left over. Then I just use Ohm's law to find my remaining resistance. And then as a final check, I can do, 12 1 over x plus 12 4 1 over x equals. But can also look at it and say, well, that's my lowest, and the total was smaller than the lowest. So I'm feeling good about that right there. All right. Yes.
So, I know the.
You have to say a quick
total
question
was
first, or it
9.
doesn't count. What? You have to say a quick question first, or it doesn't count.
No, it's a long question.
Okay.
So I know the total resistance on the last one was 9 ohms.
Total resistance on the last one was in fact 9 ohms.
Now, if you wanted to double check that it was 9 ohms.
Yep, I did.
Even after doing
3.
the Ohm's law.
3 plus 6 right here is 9.
Oh, okay, there. Okay, so you wouldn't double check it using the first.
Here? Sure, you could. 12 1 over x plus 4 1 over x equals 1 over x plus 6 equals 9.
Oh.
Because these two together would have gave you 3 plus 6 would be 9.
Okay.
So yes, I guess no matter what you do, just double check. All right, let's see. So I'm working off a sheet that looks like this that somebody left in the office. We did 7.
Really?
Thanks, Matt. All right, so let's. We did the upper left. We did 7. We did 8. Let's just drop right down to 12 and see if 12 is something that we can handle.
Drop down to 12.
Ooh boy. Okay.
Result resistance.
This sheet 7, 8, 9, 10, 11, 12.
Oh, I thought you meant like a total of 12. I was like, God, this is
All right,
ridiculous.
so here we
There's a
go.
lot.
So this one looks like this. All right.
So it does have 12 resistors.
Yeah, but I'm already done.
Yeah, I'm sure you are. He's very fast at this. He's just not accurate. So we'll do this E-I-R there. All right, what are my givens?
You tell me.
It is 24 volts. It is 6 ohms. It is 12 ohms. It is 6 volts, 3 amps, 6 ohms, and 3 ohms. Good luck. Okay, so let's solve this. So it is. We can simplify it into 3 resistors in series. So these are parallel, series, parallel. So not a problem. So blue will be our givens, and so well, so we've got 3 amps here. So that just made the whole thing real easy. So 3 amps,
I honestly think this one's easier than the last one.
3 amps. I just do.
All of them.
Okay. What else can we fill out?
The
R
total.
I told
R
R3.
total.
Okay.
6
I
divided
total.
by 3 equals 2. Equals reference.
So we can fill out this one right here.
Well, that's different.
This is R1 plus 2, R3, and R4 plus 5. What can we do?
Find R3,
Okay, R3's resistance. What is it?
2 resistance.
2 ohms.
2 ohms. All right. Now what?
We can find the total resistance on the left side.
Total resistance. Okay. 8. Doesn't really help much. But you can. You're right. Now what?
Find the combined resistance for 1 and 2.
There we go. R1 plus 2. So 6 1 over x plus 12 1 over x. We get?
4 ohms.
Okay, 4 ohms. Hope you're not lying to me. Do the same down here.
2 ohms.
2 ohms. All right, that makes it kind of simple now. We've got
12 volts.
12 volts and
6 volts.
6 volts. Wow, that was pretty easy. All right, so we can just fill stuff in. So 12 is going to come over to here. 12 volts. 12 volts. So now we can just solve for the amps. 2 and 1. And 2 plus 1 equals 3. So we're looking good. Right here we've got, just bring this down. 2 comes right over to 2. Volt. Oops. It was a new way of writing it. Okay, 6.
And 1 amp, 2 amp.
6 volts. 6. Ohm's law. 1 amp. Ohm's law. 2 amps. I think that was even easier than the last one.
What I said at the beginning.
I'm telling you.
One more?
All right, one last one.
You guys are fucking kidding.
Unless you don't want to.
You just gave us that paper, Kevin.
What color?
It's taking me longer to draw this thing out.
So, like, once you get here, so three.
Gonna add a motor.
Six.
Right.
So then you go here, you put in 6 volts because parallel.
Okay. But then here you wouldn't change it.
Nope.
Oh, why stop there?
These stay the same.
I'm not ready. Wait, but your old paragraph.
Series of parallel series is.
These stay as the
It's old
original.
parallel.
So when you break it back down, you have your
I'll give you the givens here. 24.
That end one was-
and
I can
then
go without.
you're
24
giving
volts.
6 amps. So
I already saw the Kevin.
divided by
12
6
ohms.
And then
6
so
ohms.
they get the 2. So same
A lot
up
of
here.
6. Jeez, okay.
You found the
6 ohms everywhere.
So you just plug it.
The double with that.
And then do
Kind of looks that way, doesn't it? All right.
They did that on purpose.
All right, let's solve this one. It's so simple. Okay, first thing is we've been doing everything and converting it to series, but now we're not going to convert this to series. We're going to convert it to parallel. So it's 1, 2, 3, 4, 5. So we're going to simplify it that way. All right, so this is, let's see, we'll keep it. So 12 ohms, 6 ohms, 6 ohms. And how many ohms here?
3.
3 ohms. And this is
4 ohms.
4 ohms. But I got to simplify a little bit more. So it becomes 1, 2, 3, 4.
9 ohms.
So-
Oh, I see.
This is 12, 6. 6 plus 3 is 9, and 4 stays 4.
Wait, what?
9 what, Kevin?
I'm working on it. Okay, see? Right to left to right. All right, so
That's,
Still got 24 volts.
it was a 24 volts. How many ohms do I have total?
31 ohms.
Can't be 31. It's got to be less than 4.
1.636.
How much?
1.636.
1.636 ohms total.
Total.
Okay, so my total current is then
14.67.
14.67 amps. All right. So I can even solve, I'll switch it to red here. I can solve all this. This is 24 volts. 24 volts. 24 volts. 24 volts. All right, so we have 2 amps, 4 amps, 2.67 amps. And remember, this one is a combination one here. I didn't label it real well. And over here we have 6 amps. Well, this isn't going to change all the way up. So we can even fill it in. 24 volts, 2 amps, 24 volts, 4 amps, 24 volts, 6 amps. All right, but this part right here is going to change. So we're going to roll up a little bit. So we have these two right here in
Series.
It's-
Just pull my phone up from the computer.
267.
Have a picture of it.
all right, so we have coming into here 2.67 amps. And the 2.67 amps is going to flow through the whole thing, right?
Yes.
And now we can use Ohm's law to solve for the voltages. So I don't have it with me here. 2 points. So what does my voltage end up being? Let's see.
16 and
E equals I times R, and I want to solve. I want E. So what am I going to do? Are you guys with me?
I'm just not yelling back yet.
Where did I lose you?
everywhere.
Everywhere. Do I have to slow back down?
Better start all over.
You lost me on when you distribute the series and the parallel back in.
Okay, so we'll come back. Did everybody follow me on this one right here? Raise your hand if I lost you. Don't be ashamed.
To combine the 3 and the 4 and the 5, you just add the ohms.
Are you talking about going back up?
Yeah.
Where did I lose you?
So you add the ohms for 3 and then 4 and 5.
3 and 4 and 5. Where were we talking? Resistor 3, 4, 5 or ohms
Yeah.
3? Okay. Yes. So we have 3, 4, 5. So this one right here remains R3, and this one is R4 plus 5. And then this is R3 plus 4, 5. So it's all of them. This one right here is all of these right here. So I brought it all the way down until I just had one resistor in each branch.
Okay.
And then I can solve the whole thing.
Okay.
All right.
So what-
Then, make sure that's still on. Okay. Now I'm working my way back up. So working my way back up, R1 stays the same, right?
Yeah.
24 and 2 stays the same. 24 and 4. This is different. This becomes my battery feeding into that. Okay? This stays the same. 24 and 6. So R1 stays the same all the way up. This stays the same. But here's our problem right here. So this is the battery going in. So I have a battery, with 24 volts, 2.67 amps, and 9 ohms feeding a series circuit. All right? So feeding a series circuit. So what stays the same in a series circuit?
Car.
Amps. So my amps just stay the same. So 2.67 amps and 2.67 amps. The 3 ohms and the 6 ohms, we had worked on our way down, and now we're working our way back up. All right, so again, 24 volts. Now, that 24 volts is going to split across these two, but I don't know how, but I'm going to use Ohm's law. So E equals I times R, so 6 times 2.67, 6 times 6.27. That was not right. 6 times 2.67 equals,
16.02.
thank you, because I ended up with 96 something. I know that's not right. How many?
16.02.
16.02. And then what's left here? 3 times 2.67 is 8.01. So 8.01 volts. All right, so now we're going to scroll up a little bit more. And now we're going to take, this is my battery feeding this circuit right here. It's easier to think of it coming down, but whatever. So I have a battery. Well, I'll take that back. I shouldn't have done it that way. Hang on one second.
Right.
I'm going to make it a little easier. I'm like, wow, you make something easier. This right here just moves up. That's the answer for right there. So 1602, 16.02, 2.67, 2.67. And we can look at it this way and say, all right, or I can say, let's see, this becomes the battery in yellow feeding these two right here. So that battery's got 2.67 amps and 8.01 volts. So what can I do with those volts? 8.01 volts. 8.01 volts. And
267 divided by 2.
and 2.67 is going to divide out by those.
By
Actually,
two.
right in half because it's
Because it's the same
even.
resistance.
So, but we can use Ohm's law. So I equals E, 8.01 divided by 6 equals 1.3 amps here, 1.3 amps here. 1.3 times 1.3 is 2.67. So let's think this through a little bit. I've got 24 volts coming across. I got 24 volts, 24 volts, 24 volts. Coming through this one, how many volts should I have? 24. I have 16.02 plus 8. Is that 24?
Yes.
Looks like it to me. Coming through this branch right here, I have 2.67 amps. It's going to come down and split off. Half are going to the right, half are going to the left. 1.3 plus 1.3 is 2.67. It checks out. I didn't fill this in right here, but it's right down here.
So I have a question on this last part right here.
You have to raise your hand.
No, right.
Alex, you have a question? Yeah.
That last resistor, it's a series resistor. How did that turn into a parallel?
This one right here, how did R3? How are you talking about R3?
Yeah, R3, and then all the equations you did on the bottom, like everything, all the numbers, it was like parallel pretty much.
Well, okay, so each one is a parallel branch.
Yeah.
So I kept this as a parallel branch, kept this as a parallel branch, and this is a parallel branch, but this is also parallel, but I brought these two, 4 and 5, together into one. See, so, right, these, I brought these two together into one. That's right here, R4 plus 5. R4 plus 5, right here,
And then
4 and
the R3
5.
changes into parallel.
And then I have these two. Are they in series or parallel with each other?
Or in series.
In series with each other, so I can add them up in series to right there. That's how I did it.
One more time.
Yeah, one more time. I didn't
All right.
understand anything since the word welcome to class.
Yeah. Okay. I have good news and bad news. The good news is I only have one piece of bad news. No, that's not how it works. Okay, so the good news for you is that as far as I've ever seen, the FAA test questions require you to determine total resistance in a circuit like this. They do not require you to work it back out and do. So they might ask you to achieve the totals. So if you can do the totals for the resistance, get R total, and then figure out I total, you're going to be fine for the FAA tests.
But for their test, do they give?
But the bad news is I'm not that way.
But for
Yeah.
the FAA, do they
So basically, what you're saying, the FAA. Basically, what you're saying is the FAA just will ask for the totals.
Yes.
And they'll give
That's
us
what he
all
just
of
said.
that.
No, they will.
Will they only give you the resistance?
They'll give you everything here in the blue.
So
And
they
this
give
one right
you
here,
resistance.
give you everything in the blue and ask you to solve for R total. And maybe I total. That's it.
So then we'd still be good to figure out the rest of all.
If you want to, but you don't have to. But you should know how.
Okay.
All right?
Kevin's gonna ask you.
Well, yeah.
Because I will.
obviously.
Remember
Okay.
you said on day one you will be overqualified for the FAA test?
You'll be well prepared.
You gotta make it there first.
Yeah, I got to get through me first. All right. Now what?
So do you have one like a series parallel on the
Yeah,
test?
you have more questions.
Do I have one? Yes, I do. I don't think I have anything as difficult as we just did.
Oh, thank God. I say, if it takes 20 minutes to do one problem.
But where are we going to go from here?
Saturday on this bad runner.
I don't think I have anything that's more difficult than what we just did. All I can do is just.
What about anything equivalent to what we just did?
Okay, what I'm going to do. Let me see here.
No handout?
Got a handout, or we can review.
Handout.
Handout. Wild. Review the handout.
Handout tomorrow.
Handout is review.
I'll pause this while we discuss.